double integral over rectangle. So we have a double integral y plus xy to the negative 2 dA, and then the rectangle is xy is on the xy plane where x is between 0 and 2, y is between 1 and 2. Here is how I picture this problem in my mind. The integrand is y plus xy to the negative 2. That is a function which is z equals to y plus xy equal to the negative 2, or you can take that as f of xy. So imagine this. The f of xy is a piece of paper that you are holding over your table. So that is three-dimensional, right? Holding on your table. And then the shadow is on the xy plane. The xy plane is your table. And then if you check out the shadow is actually a rectangle where x is between 1 and 2, 0 and 2. X is between 0 and 2, y is between 1 and 2. And we will have to set up a double integral. So that will be a double integral. And then I have the integrand y plus xy to the negative 2. I am going to do a dx dy integral first. So dx dy, the x is between 0 and 2. I will write x is from 0 to 2. And then y is from 1 to 2. So y is from 1 to 2. And then you do the dx first. Okay, so the dx, the 1 to 2, we are going to just drop it right there. And then x is a variable, so the integral of y is just an integral of constant. Then we have xy, and then plus the integral of x, 1/2 x squared. Y to the negative 2 is just a constant, so such that x goes from 0 to 2. So you are plugging in the 2 and the 0 to x. All right, so that is equal to integral from 1 and 2, and then you plug in the 2, you have a 2y, and then plus 4 divided by 2 is 2, so 2y to the negative 2, and then you, what do you do? So once you plug in the 0, they are all gone, right? So once you plug in the 0, you have the 0 right there, and then the 0 right there. So basically the whole thing is just equals to 0. And then this is a dy, and then I forgot a dy right there as well. So this becomes a single variable, right? So y only, and then the integral of 2y, that is a y squared. The integral of y to the negative 2, so that will be y to the negative 1, right? And then you have negative 2 in front. So when you take the derivative of that, you can get the integrand back. You know what? It's negative 1. Negative 1. All right, so bring the negative 1 down, plus 2, negative 2. All right, so y goes from 1 to 2. So when y is equals to 2, so this one, let me just give you the answer. The answer is equals to 4. So this is a, what is this? This is a dx dy integral, from a dx dy integral. Now, can we do dy dx? The answer is yes. Let me do it right now. So if you want to do a dy dx, then this will be a double integral, and then y plus xy to the negative 2, and then we do a dy dx. So y is from 1 to 2, and then x is from 0 to 2. What is the difference between dx dy and dy dx? Are we going to get the same answer? The answer is yes. You are going to get the same answer. But which one should I do? The answer is sometimes doing dx dy is easier. Sometimes doing dy dx is easier, depending on the interval, on the integrand. Sometimes dx dy, you can probably do it in 2 minutes, and then when you switch over to the dy dx, you might have to do a bunch of u substitution, integration by part. You end up have to spend 10 to 15 minutes to find an integral that you can complete in 2 minutes. Okay, so really depends on the integrand. Okay, so we are integrating this. So what is the integral of that? The integral is, so that this one is 1/2, right? Oh, I should start with from 0 to 2. And then y squared, right? And then what about the negative 2? That will be a minus x to the times y to the negative 1. Take the derivative, you get definitely miss the 1/2. Take the derivative, you get the y plus xy to the negative 2. All right, and then y goes from 0, not 0. Y goes from 1 to 2. And then this is over a dx. You have 0 to 2. You plug in a 2 to a y. You have a 4 over 2 is 2. And then the other one, you have a 2 to the negative 1, so x over 2, and then a minus, plug in 1 to a y, you have a 1/2, right? And then plug in 1 to y, you have a minus x, but this is in the parenthesis, so once you subtract that, then that will be a plus x. So I can just get rid of this and then change this to a plus x and then a dx. So now we are returning to integral calculus, and then the integral of 2 is the integral. The 2 and the 1/2. Okay, so 0 to 2, 2 minus 1/2, so that is a 3 over 2, and then negative 1/2 plus 1, that is a plus 1/2 x, and then dx. Oh, this is easier. So integral of that, 3 over 2x plus 1 over 4 x squared. Take the derivative, yep, we get a 3 over 2 and then a 1/2. And then from 0 to 2, plug in a 0, everything is gone. So you plug in a 2, you have a 3 plus 4 over 2. 1 over, no, not 4, 4 over 4, 1. And then minus, you plug in a 0, everything becomes a 0. So that is also equal to 4. This is obtained from a dy dx integral. Okay, so you have this problem, the integration process, you have the same difficulty. Sometimes depending on the function, sometimes the dx dy, again, you can do it in under 2 minutes. But if you switch over to a dy dx, you might have to do a bunch of integration by parts, use substitution, partial fraction, who knows. You might end up have to spend more than 10 minutes to do a job that you can do it in 2 minutes. Alright, so that is the end of this problem. If you like the way I explain double integral over a rectangle, thumbs up for this video, subscribe to my channel for more contents like that. I meet you all in the next one, signing out.